right, so again, thank you all for joining us this morning. Today's program is Studying Earth from Space. You're going to join Professor Stephen Young from Salem State University as he gives us a tour of planet Earth from space. In this multimedia presentation, he will explain how satellites image the Earth and how we use these images to better understand our planet. And as I mentioned, this is a family-friendly presentation with time for questions at the end of the presentation. So all 20 of us watching live and the hundreds that are going to watch on demand, let's give a big round of applause to Stephen for joining us here this morning. And Stephen, you can take it away. Thanks so much.
All right. Thank you very much. Can everybody hear me okay? A little thumbs up if it's okay, good. I'm excited to be here, getting used to our COVID world and speaking remotely. Usually I really enjoy in-person presentations, but I'm impressed at how we're able to transfer into a new kind of mode. I am a professor at Salem State University in the Geography and Sustainability Department. And I use satellites to study the Earth, and I teach how we use satellites to study the Earth. And so today I'm going to talk about how we use satellites to study the Earth, a little bit of the history of it, and do save your questions for the end, and we can have some conversation at the end. And if you've got comments along the way, you can pop them into the chat. I may stop at an image or two and ask you some questions about it, and then you can put information in the chat there. So let me get started here. So I call the talk the Earth Exposed, because through satellites we're able to see things that we normally can't see with our eyes, and so we expose a lot of things that are going on planet Earth. This is an absolutely beautiful image. This is from a European meteorological satellite. It sits about a quarter of the way between Earth and the Moon. So it's way out there over the Gulf of Guinea, and continually images this half of the Earth for meteorological purposes. Oops. So here is the first image of Earth in the United States from above the surface of the Earth. This is in Boston, 1860, October 13th, 1860. And although there were a couple of images taken in France from above the Earth, these are the oldest ones that still exist. And you can find these in the Boston Public Library. This was in a balloon, hot air balloon, over the Boston Common, looking out towards the harbor. It didn't take long before the military realized the potential of aerial imagery. And this is Thaddeus Lowe. He worked for the Union Army, and he would go up in a balloon and take pictures of the Confederate locations and arrangements, and come down and process the film, and then eventually use it and see where the Confederates were. This is San Francisco, 1906, after the earthquake. And a photographer from Chicago went down there, Lawrence. And he used, here's his camera, and he used kites to lift the camera up above the surface of the Earth, as we didn't have planes at that time, or just starting. And actually, until just recently, we used kites continuously for imaging, for photography. With drones we can control a lot better than kites, so we don't use kites as much anymore. But until about 5 years ago, we still did kite photography. And this is one of the images that he took from his kites. And it was a devastating fire that occurred after the earthquake. And like a lot of American cities that were primarily built in wood, a lot of cities have their history of devastating fire. this image is often referred to, or this style is often referred to as a bird's eye view, because it's almost like you're a bird looking down on the earth. And in fact, in the early 1900s, a German photographer decided to use pigeons. But pigeons are actually amazing animals. And so he fit them with these cameras and had the shutter go off every 15 seconds. He was actually a landscape architect, and this is a book that he put together with the imagery. And sometimes the bird's wing would get in the way. Sometimes they're crooked images, but it was pretty amazing to get those images. And this is a pigeon that's in the Smithsonian Institution. And we had over 600 pigeons who worked for us in World War I. And they would fly reconnaissance missions, and they would fly out and then come back, and then we would get the film and view the film. And you have to admire this bird. That is a camera that is made of heavy metal. And the fact that that bird can carry that weight and fly and go on a mission and come back is pretty impressive. And so we were able to get a different perspective from above. And as soon as planes came about, we put cameras on those planes. Wilbur Wright is considered the first aerial photographer. And this is Salem, Massachusetts. And this is in 1914. Like San Francisco, Salem had a major fire that burned a large part of the city. And this is the first aerial photograph ever published in a newspaper, and it was in the Boston paper. This is a U-2, a plane, high altitude plane used for reconnaissance that we used to image the Earth. And then the Apollo missions. Our mission was to get us to get a human on the moon before 1970. But in the process, we experimented with a lot of different cameras because we had realized the power of imaging. And this is 1962. This is an image that John Glenn took, and it is over the. Here we've got the Atlas Mountains in Morocco, and so the plane left, or the rocket left Cape Canaveral, and headed over the Atlantic Ocean. And as he went over Northwest Africa, pulled out his camera and took a picture. And it's kind of interesting. He bought the camera a week or so before the flight, and just wanted to take a few pictures, show mom where he went. And when scientists saw these pictures, they realized the power of imaging the Earth from a distance. And we can see things and see patterns in a much different way than we can on the surface of the Earth. And certainly these images that came back of Earth from space, these are some of the most powerful, although it's photography, not satellite imaging, some of the most powerful, what we call remote sensing, imaging something from a distance of Earth, and realizing that we are this planet in space, and we're not getting any new material, and we're not able to send material, really much material, away from Earth, and then we get our energy from the sun. So it was pretty for the environmental movement. It was pretty astounding imagery of Earth. This is the space shuttle. We use the space shuttle to experiment with a lot of imaging techniques. Here is the Endeavour, and it is over New Zealand, and we had a lot of experimentation. Now we have the International Space Station up there. This is from about probably 8 years ago. It's over Mongolia, and we've done a lot of experimentation with imaging from the space station as well. And the imagery that we took from the space shuttle, you can search it and download the imagery. Imagery that's captured at the International Space Station is available for download, so you can go and grab those images as well. And satellites. This is what I mostly work with. This is a satellite that over the island of Crete. It was just released from the space shuttle when this image was taken. And at Salem State, we have access to a lot of different satellites that we use in our research and our teaching. So I'm going to talk a little bit about the basic principles of satellite imaging, and then a little bit about what I do and what I use it for. Perspective. So here, this is a volcano, and the bottom image is what we call the horizontal perspective, how we normally see as we walk around. The middle image is what we call an oblique image, where we look we're looking down on the Earth, but at an angle. And the top image is a vertical image, where we're looking straight down. Most satellite images, most aerial imagery are vertical images. And the reason why is because the scale of that image is relatively the same. It's not exactly the same, but relatively the same throughout it. The oblique image in the middle, if there was a car in front of, or let's say a bus in front of the volcano and a bus behind the volcano, the bus in front of the volcano would look big and the bus behind the volcano would look small. Where on the vertical image, they would look the same size. And so that's why we mostly use vertical images, but we do use the obliques also. All right, this is my first question for you, and where in the world is this, right? I'm a geography professor, and I want to find out, so pop in the chat where you think this is. And I'm gonna look in the chat. Italy, okay. Brianna, thank you. Definitely, got it. This is an image from the space shuttle, and it's an oblique image. We're looking at an angle. It's what we call a normal color image. It's what we would see with our eyes. And this is the island of Sicily, and here's Mount Etna, and it's spewing a little bit of aerosols or particles into the atmosphere. It's got some clouds around the top of it. And one thing that I always find amazing actually is how thin our atmosphere is. Although you step outside and you look up and it looks like our atmosphere continues forever. Most of the molecules in our atmosphere are at the bottom 6 kilometers, the bottom 4 miles of our atmosphere. It really is kind of a thin veil. Okay, here's Italy again. And this is from what's called the MODIS. This is from there's a thing called the Terra satellite that is up there that has a number of different sensors on it. One's called the MODIS. I use a lot of MODIS data. And this is not a normal color image. This is actually, it uses 2 infrared wavelengths and the green band of the visible spectrum. And I'll talk about wavelengths in a minute, but it is not what we would see with our eyes. And so some of the things that we use satellites for, here now you can see Mount Etna, and you can see the aerosols spewing out from here. And so volcanic eruptions can disrupt the Earth system. There have been volcanic eruptions, Mount Pinatubo in the Philippines in the early 90s. For 18 months after that explosion, global temperatures decreased because there was so much soot, so many aerosols, particles in our atmosphere, that it reflected sunlight back to space, that it actually cooled the Earth. Back in the early 1800s, there was an earthquake that went off in Indonesia, and Vermont had snow on the ground every month of the year that it made it so cool. And so we study these aerosols. So scientists use satellites to study the aerosols. Obviously, we look at clouds. Meteorology is a huge use of satellite imagery. Up here in the Alps, we can see ice. So one of the areas that I use satellites for is I study snow cover and change in snow cover. And so some people also look at glaciers. And most of the snow, ice, and glaciers for the past 20 years have been melting and continue to melt as our world warms up. And so we use satellites to study the glaciers. You can see the dark green and the light green. The dark green are forests. The light green is agriculture. So we study land cover. You can see the ripples in the ocean here. We study the physical surface of the ocean. Oops. And oops. And then there's this kind of, you can kind of see this kind of light gray up here. Northern Italy is the industrial part of Italy, and that is air pollution. And nowadays, there is virtually one of these gray smogs from Cairo to Beijing. And so we use satellite data to study the different chemicals that are in our atmosphere. There's one other thing I want to show you. This light green, if I can get there right up here, this is phytoplankton. And so we can study the beginning of the food chain in the ocean. So this is photosynthesis that's happening in the ocean. And so it produces food that the small fish eat, then the bigger fish eat the small fish. And so we have a good understanding of the food availability for fish in the ocean. So these are just a few of the examples of what we use the imagery for, just looking at this one image from one sensor. All right, where is this in the world? I'm going to ask people to pop that into the chat. And by the time I get to the chat, hopefully someone has Egypt, thank you. Right, that's the Nile Delta. And so there's a couple things here. First of all, if I can get there we go. The Nile Delta is one of the most densely populated places on Earth, right? Egypt is the most populated Arab country in the world, and a lot of those people live up there in that delta. And you can even see some of the large Cairo's down here, and then you can see some of these large cities in there. It's a desert nation, but the Nile brings all this fertility and water. A couple things also in this image. Look at here is a border between Egypt and Israel. We can see Israel's got access to water. Some people say that the only sign of humans from space is the Great Wall of China. Well, there's virtually not an image of Earth that we can't see some human activity on. And that's an example of that. What I want you to look at, though, is the edge of the delta. It's very smooth. We can see some phytoplankton and some silt. It's a very smooth edge. And so geomorphologists, people who study the structure of the Earth, use satellite imagery. And this tells us that actually there's not a lot of silt that's coming down the Nile River. And a lot of that silt is being stopped before it goes out to the ocean. Here, the next slide is a different delta. Anybody tell me what delta this is? Take a look at it and let's see. So far, we're batting 1,000 here for our geography questions. But I haven't seen an answer yet. New Orleans, yes, this is the Mississippi. Again, this is not a normal image. This is an image I created. I used the blue wavelength and 2 infrared wavelengths to create this image, although it looks just like you'd be looking out of a plane window. This is a combination of over a dozen satellite images. Notice there aren't any clouds. I had to get a bunch of different images at different times of the year to make it cloud free. And, but it looks like a single image. Now, a couple of things I want you to look at that I think is fascinating. So here's the river. Here's New Orleans here. And here is the current delta of the river. You can tell there's a lot of silt. The way that there's all this marshland here, the silt builds up and it forces a different exit way, then it forces another different exit way. I want you to look over here. You can see this kind of pattern that's over here. And what this is, these are farm fields here. And the reason why these are farm fields here, this is very rich soil because this used to be the Mississippi River. Mississippi River used to come down here, and then it deposited here. Used to be an old delta. Here's another old delta. Here's another old delta. The Mississippi River actually over time, because of all the silt that it brings down from the central part of the United States, the silt builds up, and then eventually the river breaks and goes into a new channel. It's not doing that now because we've built up these levees. We've built up the edge of the river. We want it to keep flowing in the same direction because we've built these ports in order, we have a lot of ships that come and go through the Mississippi River. And so we don't want the Mississippi River to change its course and come down here because of the infrastructure that we've built up. But the geomorphologists again can use this and we can see a very, very different delta. Anyway, I think that's just a beautiful image. Oh, I've never noticed this before, but I've just noticed you can tell here are two different satellite images. There's the silt from one of them and there's the line there. Clearly that, All right. Here is an image. This is actually from a plane, and this is a vertical image over a farm field in France. And what these are, you can see the squares. These are old Roman villas. And this farm field was farmed for hundreds and hundreds and hundreds of years. And people didn't know that actually there was this old village that was underneath it. Here's the horizontal image taken at the same day as that vertical image. And although you can kind of see these lines, the farmers didn't know. And by looking down at that vertical perspective, we were able to see these lines, and then they dug it up and they found these old Roman villas. In the 1950s and 60s, all throughout Europe, they flew planes searching for these old Roman ruins in farm fields. Even though most satellite imagery and most aerial imagery cannot see through the ground, the surface of the Earth indicates what's happening underneath the ground. So here we have an old wall, and because of that, the grass or the wheat or whatever crop above it doesn't grow that well. And so it tells us that there's something underneath there. In other cases where there are old canals, there's really deep, rich soil, and the grass grows really well. So we can look at the surface of the Earth, and it gives an indication of what's underneath it. And archaeologists use satellite imaging quite a bit to help find old ruins. All right, that's perspective. That vertical and oblique perspective helps us see the Earth in a way that we normally don't see the Earth. Scale, here is this is a place in Switzerland. And this top image we call a large scale because things look large. And this is the same place. This is a small scale because things look small. Geographers were always changing scale depending on what we want to see. In large scale imagery, we can see a large area. And so we can see how this area is related to each other, but we can't see a lot of detail. But in the large scale imagery, we can see great detail, but not a large area. So here I want us to focus on the British Isles. This is a satellite image that looks at vegetation, and we can't see a lot of detail there, but we can see vegetation all around the world, and we can compare how vegetation in the British Isles compares with North America or compares with Eurasia. Now we're zooming in, and again, it's looking at vegetation. The greener the color, the greater the vegetation. And with a larger scale image, we can see more detail about the vegetation. Here we're getting even a larger scale, and we can see more detail. Larger scale, this is London, we can see greater detail. And here's the largest scale that I have, we can see downtown London, but we can't see the large areas outside of it. So geographers were constantly changing scale depending on what we're interested in finding. And the third basic principle of remote sensing or satellite imaging is the energy source that we use. Perspective, right? The vertical, the horizontal, the oblique, scale, large and small. Energy source, right? What we see as white light is actually made up of different wavelengths of energy, different colors. And here is what we call the electromagnetic spectrum. And so the sun sends energy to Earth, and it sends some really shortwave gamma rays and X-rays and ultraviolet and visible and infrared and microwaves. And our eyes, we can only see in the visible spectrum. But our satellites that we study the Earth, we use ultraviolet wavelengths, we use visible light, we use infrared, and we use microwaves. Some of the astronomy satellites that look out at space, because they're outside the Earth's atmosphere, they can also use X-rays as well. And some places on Earth, we look at radio waves when we're looking out at space. But satellite imaging, we primarily use visible light, infrared, and microwaves, and occasionally we do use some ultraviolet wavelengths. So I'm going to show you some images with some different wavelengths outside the visible spectrum. And one of the fantastic things about satellite imaging is our ability to see the Earth in these wavelengths that we normally can't see the Earth. So here are 4 images, normal color images, the visible wavelength spectrum of water. And we pretty much just see the surface of the water because visible light gets absorbed in water pretty quickly. And these are images from the space shuttle. Here is an ultraviolet image in the Gulf of St. Lawrence. And you see all those little white squiggly things? Those are beluga whales. And these are whales swimming underwater. And the ultraviolet light is able to penetrate the water. And it goes down, and the belugas are highly reflective of ultraviolet light. So when the ultraviolet light strikes that beluga whale, it gets reflected. And so now we're able to see all these whales underneath the water. In the past, ecologists used to go out in those little rubber boats, and we'd wait for the belugas, or they're mammals, and so they would rise to the surface, and we'd wait till they rise to the surface to breathe in order to count them. Now we can just take pictures, and we can see how many there are and count them. Oops. Here are 2 images. On the left is a normal black and white image. On the right is an ultraviolet black and white image. Number 2 is a polar bear. In visible light, it reflects all the light, so it looks like snow. So it's hidden. But in ultraviolet light, what the polar bear does, it wants to absorb it for the heat to stay warm, and it doesn't reflect it. And so in the past, when ecologists would try to count the number of polar bears, and we'd fly over in a helicopter, sometimes it would be hard to see them because they look just like the snow and ice. We take an image in ultraviolet light, and boom, the polar bears jump right out. Snow still reflects ultraviolet light, but the polar bears absorb it. So we're able to see the polar bears. Here, this top image is a normal color black and white image. It is, if we saw in black and white, this is what we would see. And this is a thermal image down here. And so you can just make out this guy here. There's his face. He's got his hand there. He's got a gun. And in the vegetation are 2 other people with guns. We can't see them because visible light can't pass through the vegetation, but heat can. And so with this heat camera, we're able to see those people that are hiding in the vegetation. Now, here is a thermal image of an airport. The white means there's a lot of heat, and the black means there's not a lot of heat. Here's a helicopter ready to take off, and this is where it came from. One really cool thing about thermal imaging is we can see things in the past. So these helicopters, you can see the sun is shining in this direction. Here's a helicopter. It's very bright because the sun is shining on it. The helicopter is absorbing that heat. It's hot, and it casts a shadow. And the shadow is cold. And so we can see that shadow. And so here's this helicopter getting ready to go, and we can see where it came from. And we use thermal imaging to at universities or towns. We'll fly at night, and we can find leaks where, let's say, a large university has a central heating plant, and it sends through pipes the hot water to the different buildings to heat them. We can find where the leaks are of those pipes with the thermal imaging. We can use thermal imaging on houses and see where energy is leaking from our house. Anyway, using the infrared, the thermal infrared wavelengths, we can see things differently than we would with our eyes. Here's another thermal image, and this thermal image is of a volcano. So if this was a normal image, there would be a lot of smoke billowing out, and we wouldn't be able to see the lava. This actually is a vertical satellite image, and in the computer, we're able to look at it from a side angle. And because heat is not a color, we assign the warm temperatures the red color because we associate red with hot. And we give blue color to cool temperatures because we associate blue with cool. And what we see is there's a lot of hot lava flowing out of this volcano. Every day there's a volcano going off somewhere in the United States, somewhere in the world. And so we use satellite imagery to monitor for natural hazards and safety, the flow of lava. It's kind of ironic that a lot of people live on volcanoes and live near volcanoes. And that's because volcanoes spew out bedrock, spew out rock from inside the earth, and then that weathers and creates very fertile soils. And so some of the most fertile soils on earth are found near volcanoes. Like in Indonesia, Java, which has a number of volcanoes on it, Bali, which has volcanoes on it, are heavily populated near the volcanoes because of that fertile soil. And then those volcanoes are active, and so there's a lot of people in danger. And so we use these satellite images to monitor. We can actually, using satellite image, we can actually monitor the volcano. We can see bulges that start to appear in the mountains, and we can predict where the lava is going to flow out of. All right. Here's another geography question. Where in the world is this? This is a thermal image, and I'm going to let you look at it for a minute, and then I'm going to go to the chat. Anybody have an idea where that image is? Andy, you want to? Cape Ann. Thank you. Yes. So there's a thermal image. This is an image that I put together. This is actually from 1987, and it's from March. And here's Lynn. Urban areas tend to be hot. Here's Gloucester. Here's the highway that goes up to New Hampshire and Maine. Pavement absorbs, doesn't reflect energy, so we can see different roadways. And here is the rural countryside, forested. There's this light blue is ice. There's still some ice on the water. So we use thermal energy to monitor the Earth. This next image is water. And this is, Salem used to have a coal power plant. We now have a natural gas power plant. But the coal power plant would cool itself down and it would dump the hot water into the harbor, and we can see the thermal pollution that the power plant created. All right. I just wanted to show you a few applications that we use the satellite imaging for. This is a thermal image of a forest fire out west. And the forest fire is so hot and the smoke is so hot. If this was a normal color image, you wouldn't be able to see anything down here. But what we can see is this is the burnt area that's still hot, and this is where the fire is actually happening. And there's smoke jumpers where we actually fly and we drop people to fight the forest. And so we use this imagery because we don't want to drop them in the fire itself. We want to drop them where they can fight the fire and be safe. And so we use a lot of satellite image to study the forest fire. there's a graduate from our department who works for an insurance company, and he uses this imagery to monitor forest fires and let people know that that have insured with the company that the potential danger of forest fires. Here is a hurricane that it's called a cyclone in Australia. Here we can see the Great Barrier Reef happening here. And so one of the biggest applications for satellite imaging certainly is meteorology and studying the atmosphere and getting us warnings for oncoming hurricanes and storms. This is, I'm not going to ask for the chat, but do you know where this is in the world? I'll give you a hint. There's this island here we've already seen today. This is Sicily. Here is Greece. And this is Libya. And this is dust going into the atmosphere. And with human activity disrupting the surface of the earth through overgrazing, over agriculture, there's more and more dust coming up into the atmosphere. And I don't know if you saw the news, this early June, there was a tremendous dust cloud that came over from the Sahara Desert. And actually, it's not uncommon. It's been happening for millennia, where every now and then dust comes from Africa. And actually, it brings a lot of nutrients to the Amazon basin. But it's gotten worse and worse, and we can monitor this with satellites. This is off of Namibia in southwest Africa. And this is the Naneb Desert, one of the driest places on Earth. And this is phytoplankton. This is one, there's a lot of cold water that's coming from Antarctica, and there's deep, what's called upwelling, water that's rising from deep in the ocean, and it's filled with nutrients. And one of the richest places in the ocean happens to be right next to one of the least richest places biologically on land. How about this? Take a look at this. Anybody know what part of the world this is? This is a normal color image of snow. And so one of the types of imagery that I use is this image. I look at snow cover, and you might notice down here Cape Cod and the islands. This is Nova Scotia. Prince Edward Island is in here, covered in ice. And take a look up here. There's this big circle up here. Oops. This is the Manukudenkuden Crater. About 300 million years ago, a meteorite struck the Earth up there. And there's still the scar of that meteorite striking the Earth. And with satellite imaging, we've been able to find these craters all around the world of times that the Earth got hit with large craters. I find this image actually a beautiful image. I love how the clouds kind of circle and we zoom in on our part of the world. Here's the Amazon basin and Amazon River, and then here's deforestation. And this is called fishbone scale pattern because they build a road and then they deforest as far as they can pull the logs to the road, and then they build another road, and they deforest it as much as they can. They build another road, and the area that stays forested is just too far from the road to pull it back. And so we use satellite data to monitor deforestation. And by the pattern that we see, we can tell how they're deforesting it, what's causing the deforestation. And here's an image of the Amazon basin. The purple is forest, the green is open areas, and that's the Amazon River. Here is, so not only can we image the surface of the Earth, but with satellites, we're actually able to measure components in our atmosphere. We're able to measure how much carbon dioxide there is in our atmosphere. We're able to measure how much oxygen there is in the atmosphere. And this image you might be familiar with is over Antarctica. And this is depletion of ozone. And so the yellow and reds are high levels of ozone, and the blues are low levels of ozone. So every winter for Antarctica, it's our summer, a hole opens up over Antarctica with depleted ozone. And ozone absorbs ultraviolet radiation from the sun, and so it's a protective shield. With satellites, we're able to monitor that. Here's kind of a fun image. This is South Korea, and this is North Korea. South Korea is about double the population of North Korea, but this is in the year 2002, and this is a recent image. And we can see this is the night light. We can see South Korea has increased in its night light. North Korea has changed. In fact, it's diminished. And we can relate economics actually with light at night. I'm going to go through a couple of images here. This is Venice. The red actually in this case indicates vegetation. This is an Indian satellite. There's the Grand Canal that goes through Venice. And Venice is very susceptible to sea level rise. It's right in the middle of the ocean, and they're gonna have to try to block off the greater ocean, but it's gonna be difficult. Venice's days are numbered. These are the Maldives in Indian Ocean. This is a satellite image of a glacier in Iceland. And the closer these lines are together, the more activity there is. And so we can actually see, based on this movement of ice on top of the glacier, that there's a volcano exploding underneath the ice here. And so we can actually see through the ice based on the motion. So a lot of satellite images don't look like what we normally see with our eyes, because this is using microwaves or radar imagery. So briefly, my work, I'm a field ecologist. This is up in Tibet. This is in central China. This is in the Himalayas. I was studying glaciers. This is in Australia. This is in Togo in West Africa, rainforest in Australia, Pacific Northwest in the US, Sahara Desert. Now I spend a lot of time with computers. This is my colleague Guopeng in China, and I've lived and worked in China for a long time. And this is a map of the green is forest cover, the red and the pinks are deforestation. I spent a lot of time working in China on deforestation. I also spent time at University College London in London for a year, looking at the whole world. In the 1990s, the blue and the green is increasing photosynthesis, and the reds are decreasing photosynthesis. And there was a period in the 1990s with warming temperatures, with increased carbon dioxide in the atmosphere, increased irrigation in agricultural places, that the world started to green up. So I've done global studies. As I said, I'm looking at snow cover, and this is in the wintertime. The blues are decreasing snow cover, and the reds are increasing snow cover. And in our part of the world, in the wintertime, if you haven't noticed, our snow cover is decreasing. And with the decreasing snow cover, the reds represent warming temperature, and the blues represent cooling temperature. And here's Cape Cod, here's New York State, this is Quebec up here north of us, Labrador, the surface of the earth is heating up. So I look at change in snow and change in heat cover on the surface of the earth. I also have art exhibitions that I bring to the public about what is remote sensing. I've had a show with the National Science Foundation. I had a show that toured Australia. I had a show that toured North Africa. And this part of the show, this is a normal color image of the Great Barrier Reef. Here's some of the last rainforest in Australia. And here's a forest fire. And so we can use different wavelengths of energy taken at the same time, these infrared wavelengths, you can see through the smoke. There's actually smoke billowing up, but it can see through it. And these blue areas are where forest fires will occur. They're called fire scars. So with the normal color imagery, it's hard to see the fire scars. You can see them a little bit, but we can actually see through the smoke, and see the fire scars. Here is downtown Salem, and I've modeled a sea level rise in Salem. And as time passes, Salem will disappear. The show I had in Australia showed how Australia will turn into an archipelago, and it went viral and made the front page of the Sydney Morning Herald. We use different color schemes to show intensities with satellite imaging. Satellite imaging is also very beautiful. This is the Bay of Bengal and the Ganges Delta. This is Cape Cod using different wavelengths of energy, kind of an Andy Warhol style. Macro and micro, I'm just going to briefly mention this. I work with a microbiologist, and we put my satellite images that are kilometers in size next to his imagery, which are microscopic. They're thinner than the width of your hair. And so we put our images next to each other and ask people can you tell, is that a satellite image or is that a microscopic image? And this is a satellite image of sand dunes in the Sahara. It looks actually like a microscopic image. And this is a microscopic image of a crack in a tooth with a little bit of decay. Looks like a satellite image. And we've had our exhibition at the Museum of Science in Boston, Yale University, at a art gallery in Iran. Most recently, I have an exhibition with my students about how we map climate change using satellite imagery. And this exhibition opened up last October. And so this is showing sea level rise. And the areas in yellow are going to experience sea level rise early. This is the Great Marsh up here in the North Shore. And Boston eventually is gonna get severely inundated with sea level rise. Here's a drone imagery that shows normal sea level in the Great Marsh. And then this was drone imagery taken at a king tide when we've got extreme sea level. And that's going to be the norm in the near future. I work with my students. We use drone imagery. This is in COVID, right? We're using our masks. This is Jill. She is using drones to study coastal ecosystems. And our students go and present research at national conferences. This is a student who looked at the flooding in Peabody, Massachusetts. And this is a student who worked with me in the Sudan, and the government closed off access, but we were able to use satellite imagery to monitor human rights abuses. So there's a wide range of uses of satellite imaging. So that is my show today. I hope that you find it interesting and you learned something. And with the glasses of geography and satellite imaging, we can see the world in a very different way. Thank you very much. And any questions you have, I will be happy to answer them.
Great job, Stephen. I think we can take about 10 minutes of questions. Mike wants to know, how has the pollution changed since the pandemic? So, in most places, the air pollution decreased pretty phenomenally. Right, you know, if any of you were able to go out during the lockdown, you just know, I rode my bike during the lockdown and I noticed there was virtually no traffic. And the United States, luckily,
we're pretty good about monitoring our air pollution, but places like China and India and stuff, I have friends in China who said they saw the blue sky for the first time in their life. So it was pretty dramatic. And there's a beach I go to here in Swampscott. I live in Swampscott, and I could see on the horizon, I could see land that I've never seen before. And so even here, our air cleaned up, water issues cleaned up, but that has since changed. The polluted skies are back in China and India. I can't see that landmass anymore off of it, but it showed us that there are ways in which we can tackle our pollution.
Mike has another question. What is the smallest scale that you can see?
So you know what? Now with drones, so there's a project in Salem. So Salem is building these what they're calling these living seawalls, where they're planting grasses that are salt tolerant, and so they want to monitor how much silt those grasses can collect, and over time, how high. So the salt marsh is going to rise. So using a drone, I'm able to actually see things in millimeters, which is just phenomenal. It really is, and I can fly 100 feet above the surface of the earth, and I can see things in millimeters.
Great. The rest of the chat consists of people responding to your questions. Gail says, "Terrific talk. Thanks so much." Megan has a comment. Not sure if you'll remember me or not. Oh, so this is from Megan S. Scott. Okay, Dr. Young. I had you as a professor spring 2019 for honors climate change.
Oh, Megan. Yes. Hi.
We debated a lot, and you always had us do research for both sides, which looking back was really helpful. Also, I remember talking about the grass thing because we had some people come in to talk to the class about the measures Salem was taking.
Well, Megan, well, thank you. Thank you for the comment. I hope you're well.
That's nice, Megan. Thanks for coming and showing support for your former professor. Does anyone else have any comments or questions before we wrap? Otherwise, I'll give Stephen the last word. So, Stephen, why don't you, do you have any last parting bits of wisdom you'd like to give us?
Sure. I'm glad Megan showed up. I have a deep concern about what's happening in our world, and we have a lot of issues and problems. But we've got the technology, we've got the know-how, and I'm really proud to be a professor at Salem State University because we are able to. And I go around and give public talks because I feel like you pay your taxes and you support Salem State University. And I just want to let you know that your money's well spent, and we are providing services to the public. We're educating most of our students come from the North Shore, and a lot of our students, our alumni, live and work in the North Shore. And we actually have the Geography Sustainability Department has some of the most cutting edge technologies that we use. So our students learn about how to use satellite data, how to use drones to solve our problems. And so I'm very happy that I work at Salem State, and I thank you for your support of our university. And Robert, thank you so much for inviting me to come and talk. And I would be more than happy to come back and talk on other topics. I don't know if anybody has been to my talks before in person before COVID, and I'll be there again after COVID. So thank you very much for joining me today.
Great. Well, no, thank you, Stephen. Everyone, let's give Stephen a big virtual round of applause. Great job. And just a reminder for folks still on the call, that's right, we do this now, right? I'll be sending an email tomorrow morning with a feedback survey. Within the feedback survey, there's an option to pass along a message to Stephen. So, feel free to do that as part of the survey. And a couple more chats. Thank you. And Mike says, I would love to learn more about Stephen's talks. So that's right. So thank you all so much for joining us this morning. I'm going to end the session. Look for that email tomorrow. Stephen, thanks so much. Have a great day, everyone.
You're welcome. Thank you, everybody.
Bye-bye.